What you're about to see is a thief steal a package right from my front porch. But little does he know, it's not actually a package. It's a trap box loaded with a rubber band gun and some other fun surprises. But before we look at what happened to the thief, we have to see how the box actually works. We'll start out by looking at a simple flowchart of the code. As you can see, we begin by initializing the variables and setting the system to disarmed by making the alarm toggle equal to 0. This means that every time the alarm toggle is equal to 0, the box will be disarmed. Because of that, we move down one block to check to see if the power button on the IR remote has been pressed. If it hasn't, then the alarm toggle still equals 0. If it has, then we set the alarm toggle equal to 1 and the system is now technically armed. Now that the system is armed, there are two routes that we have to go. One is over to the right where we begin reading the photoresistor values. This will determine whether or not the package has been opened. The other avenue we need to take is by going down a block to check to see if the pause button on the IR remote has been pressed. The pause button is the button that I use to disarm the system. So when the power button is pressed, it arms the system. When the pause button is pressed, it disarms the system. And we always have to check to make sure that the pause button isn't pressed, because until it enters the if statement where the thief has opened the package, we can disarm the system at any time. So now moving on, if the check remains no, we know that the alarm toggle is still 1 and the system continues to be armed. However, if the pause button is pressed and that goes to yes, then we set the alarm toggle equal to 0, and then we go back to the top to check to see if the power button, which is our arming button, has been pressed. So now if the system is armed, our alarm toggle is set to 1, and we begin reading the photoresistor values. If the photoresistor reaches a value that is greater than 500, then we know that the package has been stolen and opened by the thief. This means that we need to begin our series of deterrents. And for the deterrents, I've attached a servo motor to a rubber band gun and I've instructed it to pull the trigger 4 times. As that is happening, a speaker attached to an MP3 player chip is playing intimidating and confusing sounds. Once that is finished, the package thief should have dropped the box at that point, and we set the alarm toggle back equal to 0, meaning the system is disarmed. We can now reload the rubber band gun and rearm the system, and we can do it all over again. Now we'll take a look at how all the code is actually set up. This first block of code only initializes all the variables and includes all the additional libraries that were needed for the IR remote and the servo motor. In this stage, we initialize all of our pins for our inputs and outputs, including the MP3 player and the photoresistor. This next block of code initializes our variables that will be used for collecting data with the photoresistor and the IR remote. Additionally, it sets our alarm toggle equal to 0, meaning we have it disarmed. Next, in the void setup, we begin the serial monitor to track the photoresistor values and the IR remote values. We also start the IR receiver library and enable it to collect values to the previously attached pin. This next block attaches our servo, aptly named trigger, to pin 7, and then writes the initial servo position that was described in code block 1. Finally, to end the void setup section, all of the MP3 pins are set to output. Heading into the void loop, all of the MP3 pins are initially set to high. This is because they will remain off in the high state and they will be turned on in the low state. At this point, we also begin reading the photoresistor values and printing them to the serial monitor. Now this is where the code really gets fun. As I previously mentioned, the IR remote is used to arm and disarm the system. So we set up a switch case in an if statement which decodes the IR receiver. After a line that decodes and prints the value of the IR receiver to the serial monitor, we enter the switch statement. And the switch statement essentially says, if the case equals the certain number of that reading that was decoded, then the alarm is equal to either 1 or 0. So for case 69, that was the value of the decoded power button. So when the power button is pressed, we reach case 69, which sets the alarm toggle equal to 1, and we digital write an MP3 player set to low. Now if case 64, which is the decoded pause button, is pressed, we set the alarm toggle equal to 0, and then we digital write another MP3 pin and set that to low. Now you might be confused what those two MP3 sounds are for each case. Well, I decided I wanted to have a surefire means of knowing that the package was armed and disarmed. So I had my lovely girlfriend come in and sit down and do some sounds for me.
System armed. System disarmed.
As I'm sure you could guess, the package arm sound plays when the package is armed, and the package disarm sound plays when the package is disarmed. However, this got me thinking, what's more intimidating than my own girlfriend's voice? At least to me. So I had her stay there and say some words that would evoke fear in the hearts of any package thief.
Hey, stop that. That's mean.
Moving out of that code block, we enter the last and most important section of code for this project. So we start out at the top with an if statement, and that basically says if the alarm is equal to 0 and the photoresistor value is greater than 500, we know that the package is armed and the thief has opened the box. So now we have to start all of the deterrents that were laid out in that code flowchart. You can see we digital write an MP3 pin to low, and this plays those terrifying sounds my girlfriend gave us. Then we move on to the section that deals with the servo motor, aka trigger. For this servo, we're setting this code to different servo position. So the first one, we have it at 0, then we delay 800 milliseconds, then we set it to 90, delay again, 0, delay, 90, delay. And you get the idea until we get 4 pulls of the trigger. The reason we had to set all those delays was because the gun needed time to reload and recock in between each pull. Finally, you can see, just like the code flowchart, we set the alarm toggle equal to 0, meaning the system is disarmed and this will not run again until it is rearmed. So now that you know how the code works, I'll show you the wiring diagram that shows how everything is connected. As you can see, I kind of shot for the moon and bought an Arduino MEGN for this project. Ultimately, I did not need all the pins that I thought I was going to need, but it will be nice to have for future projects. Starting over the left, we can see that the servo motor is attached to that pin 7 like I talked about in the code, and then we attach the ground and positive wires to their respective ports on the breadboard. The green chip is our IR receiver that we set to pin 5, and then the ground and positive ports once again. We also attach the Arduino to the breadboard by supplying a 5-volt power source and a ground wire. This allows for us to power all of our external components from the Arduino. Moving over, we can see the photoresistor attached to the breadboard. This is not how it looks in my actual project, as I connected it to extension wires to be able to place the photoresistor in the exact right position to read light. And finally, as we move over, you can see the big red MP3 chip there. The speaker is connected via an audio jack off to the side, and the wires that are used for the MP3 pins are soldered onto the chip and connected to their respective pins on the Arduino MEGN. So now that you have all that info, it's time to see a build montage and a little bit of testing. So now the box is complete, but it took a while to get there. The main issue I had with the entire system was the servo motor. It ran just fine, but there was a shocking amount of torque required to pull the trigger on the rubber band gun. It took a lot of different variations of testing, but I think me from the past, very late at night, explains it much better than I could now.
Hello again. We've had a recent breakthrough in our testing since I last made that video, so if you want to come over here and look at this. So before I had mentioned that I probably wouldn't be able to get 4 rubber bands to work because the trigger requires such high torque in order to pull and ultimately recock every single time. And would you look at that? Oh my goodness, it shoots 4 rubber bands.
The final iteration uses a string that's tied to the servo motor, which is then tied to the trigger. So every time the servo turns, the trigger turns as well. And the reason I hadn't had it fully working yet was because the torque from the servo motor was pulling the entire system. Even in the video where you can see it working properly, the servo motor is still pulling the entire system up and down. Therefore, it was crucial that I had duct taped the entire system down into one place to focus the force just on the trigger. So now that we know the process it took to get here, we can finally take a look at what happened to the thief.
System disarmed. System armed.
No, stop that. That's That's mean. No, stop that. That's mean.